Hello geometry, and welcome to chapter 8 where we are going to be looking at similarity, and we're going to start with looking at similar polygons. So what are similar polygons? Well, they are going to be two polygons that have congruent angles. So all the angles will be the same measure, but the sides of the polygon differ by a scale factor. And we often use K to represent that scale factor. Not always. All right. So notice that this one has a length of A. This one has a length of K times A. So it might be twice as big. Think about putting something in a Xerox machine and you're blowing it up. It doesn't change the shape. It doesn't change the size of the angles, just the size of the lengths of the sides. All right, so yes, corresponding angles are going to be congruent, and the ratio of the corresponding sides will have a scale factor of, traditionally we use K to represent that scale factor. All right. So if I had to find a scale factor, you want to choose two corresponding sides. So if I'm going to choose AB on this triangle, then I have to choose JK on this triangle. So again, if you're given a similarity statement, and also notice, so that's how we write the similarity, it's like the top part of your congruent symbol without the equal below it. It's just a little squiggle. So we have ABC is similar to JKL. So to find the scale factor, I take the two lengths, and you always want to reduce. So 9 goes into both 27 and 36, and that would give me 3/4. So again, always reduce. Now, we want to list all the corresponding angles which will be congruent. Realize that you can just pick it off from the list. You don't even need a diagram. We know that angle A will be congruent to angle J. Angle B will go with angle K. And angle C will be congruent to angle L. Okay? All right, and then again, we want to find in this next example, HKL is similar to JHM. So the scale factor, again, if I'm going to choose HK, which is here, then I'm going to also choose GH, which is here. And it really doesn't matter which one you put up on top. I can write 15/10, or I can write 10/15. That order does not matter. But I am going to reduce. So this reduces because you can divide by 5 to 3/2. So K would equal 3/2. Now we can use this scale factor to solve for a missing side, because notice over here I am missing the value of X. And that side corresponds to this triangle 12. So I set up a proportion. I know that 3 is to 2, so that's the bigger is to the smaller. You want to make sure you keep that ratio the same. The bigger to the smaller, as X, which is on the larger triangle, is to 12. Please make sure you set up that second ratio in the right direction. And then we do that lovely cross multiplying that you guys learned about in Algebra 1. So this means I have 2 times X equals 3 times 12. And dividing by 2, we get that X is 18. Okay? Okay, whew, we have another one. All right, find the scale factor. Now, here's the dealio. If you have a third line going on, which this would actually be a median, just as a review. Notice this is like a midpoint, 16 and 16 connected to a vertex. So it will also be similar, have the same ratio as the sides. So if we're going to do a scale factor, we're going to choose the fact that this 16 is going to be related to that 36. And so I'm going to just make a ratio here. So 16 is to 36, and then we want to reduce, so they both go by 4. So this will be 4/9 is my ratio, or my scale factor. And to find the length of ST, which is here, this median is to this median. So I have smaller is to larger, as the smaller is to the larger, ST. And then we cross multiply. So 4 times ST is going to equal 9 times 12, which is 108. And when you divide by 4, we get that ST is going to equal 27. Okay? All right, now, this is what I call, we're looking at the ratio of the sides. The sides of a triangle are one-dimensional. Like if I were measuring it, my units would be centimeters or inches, nothing squared, nothing cubed, just one-dimensional. Perimeter, which just takes that one-dimensional length but adds up all the sides, the result is still one-dimensional. So for that reason, the perimeters of similar polygons will also have the same scale factor. So how do we want to say this? The perimeters of similar polygons, so they have to be similar, otherwise all bets are off, have the same scale factor. Same scale factor as the sides, because it's all going to be one-dimensional for now. We're going to be looking at area later, which will not be one-dimensional. All right, and this actually makes for a nice shortcut, because if you know the scale factor, you don't necessarily have to find all the individual sides. So we have here 2 gazebos shown are similar pentagons, and we want to find the perimeter of gazebo A. So I'm going to assume that this side is similar to this side. So my scale factor is going to equal 10 to 15, which reduces to 2/3. And then I know that the perimeter of gazebo B, if I go through and add up all the sides, it's going to equal 69. 15 plus 12 plus 9 plus 15 plus 18 adds up to 69. And so now we go to set up our equation. We know that 2 is to 3, so the smaller is to the larger, as 10 is, oh, sorry, that was silly of me. Sorry. I just had my brain just took a little vacation. I'm sure some of you guys can relate. Okay, so 2 is to 3, the smaller is to the larger, as the perimeter of A is to the perimeter of B. See, I didn't need to find all the individual sides of gazebo A. I don't really care. So I'm just going to cross multiply. So 69 times 2, actually, I'm going to show you a little shortcut here. We know that, so 69, both of those are divisible by 3. So if I were to multiply 23 by 3, it would give me 69. So I can just multiply the top by 23, and that's going to give me a perimeter of 46. And we don't seem to have any units going on. Oh, yes we do, M. Miles? Meters, sorry, meters, yeah. Okay, I hope that made sense. It didn't actually ask us to find X over here, but if I did, it would be 2 is to 3, as X is to 18. Again, 3 times 6 is 18, so 2 times 6 would be 12 if I did have to find it. All right, so in that previous page, we looked at the ratio of the sides and the ratio of the perimeter. Now we're going to look at area. Now area is two-dimensional. So if I'm including units, it's going to be like centimeters squared or inches squared. So that is going to affect your scale factor. So if I had, let's say this was a length of x, this would be a length of k times x. Then when we go to find the area of similar polygons, it also is going to have to be two-dimensional. It will differ by a scale factor, not of just k, I can't talk and write, I'm sorry, by a scale factor of, I'm going to write this in a different color so you're sure to see it, k squared, okay, where k is the scale factor of the sides. Now this is sometimes difficult to remember because when you find that scale factor, you have to square it if you're doing area. All right, so let's look at an example. In the diagram, PQT is similar to SRST. And again, we always write that in corresponding order, just like we do with congruence. The area of RST is 75 meters squared. So I don't know why it's having, this little thing came up, I don't know why. So I'm just going to put in 75 here. All right, so first thing we have to do is find the scale factor of the sides. So I'm going to go 10 is to 14, and again I'm going to reduce it, so that will become 5/7. So k is going to be 5/7, which means k squared is going to be 5 squared over 7 squared, which is 25 over 49. All right, so now when we go to do our area, we know that 25 is to 49, so the smaller is to the larger, as the smaller area, which goes with RST, is to the area of the larger. And once again, we do our lovely cross multiplying, and I'm going to get 79, oh, okay. I will work it all out so that we have all the work here. So we want 49 times 75. Whew, that's a big number. 3,675 equals 25 times the area of the larger. So dividing by 25 gives me the area of triangle PQT equals, I have to actually do it, divided by 25 is 147 meters squared. So units are going to be very important in this chapter. So you're communicating whether you're talking one-dimensional or two dimensions. Oh, I didn't even use my shortcut, which would have been better. I could have just multiplied by 3 and then multiplied this by 3. Yeah, sorry, caught that too late. All right, last little bit, we want to determine whether the figures are similar. So here is a huge cautionary tale. So I'm going to put it down here below. First of all, make sure the orientation of the shapes is the same, because you want to choose corresponding sides when you're setting up your ratio. And also, when you have multiple sides, make sure you check all sides for the same proportion, for the same scale factor. okay? This is important. And there is a nice, short, kind of quick way to do this. So I'm looking at example A here. And so I'm going to list out my numbers from small to large. So I have a 6, I have a 9, and I have a 12. And so this one is in purple. Below it, I'm going to do this one. So the side that had the 6 goes with the small side here, that goes with a 4. The side that had a 9, that goes with the 6. And the side that has a 12, that goes with the 8. So I can kind of set up, notice it's smallest to largest, which makes sense. Your sizes are not going to be changing their relative length. And what I'm trying to figure out is, are all these proportions the same? So I can reduce this one to 3/2. I can reduce this one to 3/2, and I can reduce this one, they both are divisible by 4, to 3/2. So yes, those are both similar because all the sides are proportional. So again, it's kind of a nice shortcut. You can set up smallest to largest for the length of your sides. The corresponding then should also be smallest to largest. And if you get the same ratio, you're good to go. Now in this next one, what we have to do, because they are not in the same orientation, so what I'm going to do is redraw this little rectangle at the end. So that puts, I'm going to put M and L here, okay, and this would be H, so that this is 10 and this is 4. Now I can compare. So I have, is 10 to 4 the same as 25 to 10? Now, if all you're trying to do, we're not trying to solve for anything, we just want to know if the proportions are congruent. So a nice quick way to do that is if I cross multiply and get the same number, then I know, which I do, I get 100 in both directions. So that means, yes, these two are similar. Do I have to say? Okay, if I then had to name what is similar, I would do it in corresponding order. G, H, M, N is similar to M, H, K, L. That would work. Okay, here we go again. Again, remember the angles all have to be congruent and the sides will be proportional. So I have myself a 30, 60, 90 and a 30, 60, 90. So I know all my angles are congruent. That's good to go. Now that means if I were to, again, do my little trick, notice this is 16, then 30, then 34. So we're labeling it smallest to largest. And then this one is going to go 8, then 15, then 17. Now, are these all, I guess I should say similar. Well, actually, I can say equals because it's a proportion now. And yes, these all reduce to 2/1. So these two are proportional. Okay, so if you don't want to reorient it, you know that it has to be smallest to largest, has to correspond to smallest to largest. Now our last example here, let's see what's going on. We've got 6 and 8 and 8 and 12. And so let's set up our ratio. 6 is to 8 as 8 is to 12. Does that work? Well, if I cross multiply this way, I get 64. And if I cross multiply that way, I get 72. Therefore, these are not. There had to be at least one, right? That's not similar. Bam, there it is. Okay, so I hope this was good and have a good day.